In 1981, NASA launched the first space shuttle mission from Kennedy Space Center in Florida, powering spaceflight in the decades to come. On the other side of the world, RICOH Electronics Devices was born, and in that same time, their PMICs have been used in countless devices as they've grown to be one of the largest PMIC suppliers in the world. Sanjeev Pathak, a field apps engineer at RICOH, joins us today to talk about some of the challenges in powering IoT devices and how RICOH PMICs can help solve those challenges. Welcome to Tech Chat, Sanjeev.
Thank you, Chris. It's my pleasure to be here with you today.
All righty. And for those who aren't familiar with RICOH, can you give us a bit of an overview of the company and what you guys do?
Yeah, as you pointed out, Chris, RICOH Electronic Devices Company has extensive experience in designing and building power management ICs. And we have been in this business for 39 years. We started out building MPU and then got into power management ICs. We have been designing and building lithium-ion and polymer battery protection ICs since 1995. And with our protection ICs and other power management ICs, we have enjoyed success with all the major smartphone companies in the world. Since we have our own fab, we control the production, and our designers have intimate knowledge of the capabilities of the fabs.
You know, I'm always happy to see in-house fabs because I've seen firsthand the benefits of having your own versus going through a foundry.
Two things. One is the designers understand the process and the capabilities, so they can kind of push the envelope, so to speak. At the same time, if they come up with an idea for which they don't have the process or the technology, they can put in that request and say, guys, in the next 1 year or 2 years, if you can come up with this, we can reach this milestone. And we have a keen focus on commitment to quality and reliability as well. We supply to the major automotive OEM companies and also tier 1 and tier 2 companies in the automotive supply chain. And as far as power management ICs are concerned, in that market, we have a substantial market share as we rank number 3 in the low dropout voltage regulators rated below 500 milliamp output current. Our market focus is Internet of Things, and today we'll talk about how RICOH contributes to extending the product life of customers' IoT devices.
With this focus on IoT, what are you doing to help designers?
Yes, so the focus point of the IoT market is 3 key aspects. The first one is low noise, which is especially important for sensors. We have ICs with low output noise and high power supply rejection ratios, all in one product. The second key is to be able to secure power for the IoT in a variety of conditions. And we achieve that with low electromotive force power management ICs. And the third key is ultra-low quiescent current to reduce power consumption. And summing this all up, with RICOH's solution, one can extract maximum energy from the environment in an efficient manner and then consume less power and less capacity from the battery that powers the IoT blocks. This, in essence, allows our customers to achieve long life of their IoT system.
Okay, now you have this RIoT board that showcases all of that. So tell me more about that board.
Yeah, this is the RIoT Environment Sensing Board, which is the RICOH IoT Board. As you see, the size is only 25 millimeter by 25 millimeter. This board has the illuminance, temperature, humidity, and pressure sensors, plus a storage battery, Bluetooth Low Energy Unit, and MCU. The RICOH ICs are the R1800 specialized DC-DC converter for energy harvester, the RP604 buck boost DC-DC converter, and the RP124 LDO with battery monitoring. Here we show the block diagram of the RIoT that also shows the power tree. The photovoltaic panel is connected at the input of the R1800 DC-DC converter and charges the storage battery. The output of the storage battery feeds the RP604 buck boost converter and the RP124 LDO. The RP604 provides power to the different blocks like the sensors plus the BLE plus the MCU. And the RP124 is able to monitor the battery voltage. The RP124 LDO has a built-in battery monitor, the output of which is connected directly at the ADC input of the MCU. So one can monitor temperature, humidity, pressure, illuminance, and also the battery level on a smartphone or a tablet.
And you have probably the most relatable use case example I've ever seen.
Yes, we demonstrate here a very practical application using the RIoT. As shown in the diagram, each water closet or toilet gets a door sensor connected to the RIoT board. The RIoT can figure out if the toilet is occupied or vacant. And each toilet has a vacancy indicator, and outside the restroom is a display point that tells you if any toilet is available or that you need to rush to another restroom. And another gateway display outside the restroom tells you specifically which toilet is available. What we are demonstrating with this plot is that even when the illuminance of the restroom gets very low during weekends or holidays or off days, the RIoT is able to operate successfully without a backup battery. Summing it up, RIoT integrates three key features. These features make the RICOH ICs an excellent choice for anyone who wants to design an IoT edge device. The first one is the specialized DC-DC converter designed from the ground up for energy harvesting with a photovoltaic panel. This is the R1800. The second one is the low IQ buck boost DC-DC converter with a wide input voltage range. This is the RP604. The third one is the low dropout voltage regulator with an integrated battery voltage monitor. This is the RP124. And the combination of these three ICs makes a compact, cost-effective solution for IoT applications occupying very little space on a PCB.
Now, each one of those plays a different role in the application. So can you address each one in a bit more detail?
Yeah, certainly, Chris. Let's look at the R1800 first. This is the buck or step-down DC-DC specifically designed for energy harvesting application. It requires ultra-low startup power, as low as 0.72 microwatt or 720 nanowatts. It also has ultra-low IQ of only 144 nanoamperes. And it also offers high efficiency. And it works on the principle of maximum power point control. And it is housed in a really small package of DFN, which is 2.7 by 3 millimeter. The benefit that it offers is that you can implement this in a small mounting area, and the installation is also very easy regardless of the conditions. And in the bar graph below, what we show is that if you use the R1800 and if you want to kind of maintain the size of the PCB mounting area, you will need only half the illuminance. Conversely, if you want to reduce the size and if you halve the size of the PCB implementation, then the same illuminance can still work for you with the R1800. And on the right-hand side, what we show is the efficiency curve. Even for an output current as low as 10 microamp, R1800 is able to achieve 90% efficiency. And also the R1800 is able to work with an external AC-DC converter if vibration energy harvesting is what our customers want to use.
Can you elaborate a bit more on the importance of low startup power?
The low startup power is important because illuminance is something that sometimes you cannot control. And if you are in a dark place, as we see in this slide, what we are demonstrating here is wherever you place the 1800, it can work for you. So even when you have a partially lit area because of some obstruction, or if you have just a candle light, you are still able to use R1800 because of its low startup power. And what we show here is the RICOH dye-sensitized solar cells, which has good output power and is also very safe because it's built with a solidified electrolyte. What we show here is an LED is connected to the R1800 evaluation board on the far left, on the right-hand side of the screen, of course, and it is connected to the solar cell on the right side. And in the middle is the environment sensor board RIOT 001. It is provided for size comparison. The illuminance at the start is about 684 lux, and as you can see, the LED is blinking. This is because the step-down DC-DC converter R1800 is switching. And let's see how it gets darker to 184 and then all the way down to 28 lux, and the LED is still flashing. And remember the blinking cycle. The yellow line on the graph still shows 28 lux. And you can see in the graph flowing from right to left, it has become 24 lux and it's getting quite dark. And pretty soon it will be even darker. And as you can see, the LED is still flashing at 20 lux and it will get even darker. But the flashing slows down as it becomes darker to 16 lux. So what we want to demonstrate here is that R1800 is successfully working in really low illuminance. So just to be helpful to our customers, we show on our website kind of a rough calculation. So if you plug in the minimum starting power for 1800, which is 720 nanowatts, and if you have an amorphous silicon type of photovoltaic cell of 1 centimeter square, all you need is a little over 22 lux. Now we want to talk a little bit about some of the new products that we have. What we have here is the R1801, which is coming soon. This also is a buck converter for energy harvesting. The key features of the R1801 is that the V out and MPPC are adjustable with external signals. And it also has a power good function that sends a turn on sequence signal to the system side. But what is special about this one is that the maximum power point control voltage point as well as the output voltage are both finely adjustable. Because in many cases, what might happen is that sometimes the panel characteristics might change or they may change the panel. And so then they need some fine adjustment. So R1801 allows them to make those fine adjustments. And then the R1810 is under development, but it's a boost converter. And what is special is the operating voltage goes as low as 0.35 volts.
Okay. And, you had the RP604 listed there as well. So let's talk about that one a little bit.
Yeah, the RP604 is an ultra low IQ buck boost DC-DC. The IQ is only 300 nanoamperes, and this too provides high efficiency across the board. And because it has wide input voltage range, as I had mentioned earlier, you can accommodate a variety of sources. 1.8 volt to 5.5 volt is the input voltage range. And this too is housed in really small package. For example, the wafer level chip scale package, which is only 1.7 by 2.3 millimeter, and also a DFN. And because of these features, RP604, the benefit is that IoT is able to extend the battery life, or conversely, you can have a smaller battery for the same type of application. And it also occupies a small space on the PCB. And in the efficiency curves right below that, what we show is how efficiency stays high in step down or buck DC-DC operation, as well as in boost or step up type of DC-DC operation. And that is what is unique about the RP604. In IoT implementation, what designers like to do is to reduce the active operation as much as possible and keep the IoT running in standby operation for as long as possible. And as opposed to buck converters, as we show on the left-hand side, if you have the buck boost, you are able to extend the battery life, which is shown in the table below. As you can see, if your buck boost DC-DC has a supply current or consumption current or IQ of 30 microamp, your battery would last only 51 days if you have the 50 milliampere hour type of battery. But if you use the RP604 and the IQ or the ISS or the supply current is only 0.3 microamp, you are able to run the same battery for 178 days. And I think that's substantial.
All right, so what about the RP124?
Yeah, this is a unique offering from RICOH. We have added a battery monitor to the ultra-low IQ LDO, and this is an integrated solution where we have ultra-low IQ of, again, only 300 nanoamperes. But with this LDO, the designers have also been able to achieve a fast transient response along with the ultra-low IQ. And this simplified battery monitor function is also housed in a small package of DFN, also available in a SOT package. And so the battery life is extended. You can have a smaller battery, or most importantly, with this built-in battery monitor, you have reduction in external parts. And you can see on the right-hand side below, the transient response compared to a competitor is much better, in spite of the fact that you have a step from 10 microamp to 10 milliamp in only 0.5 microseconds. So let's look at the conventional style of implementing a battery monitor. What designers do is, in order to feed the battery voltage data to the ADC of an MCU, they have to use divider resistors. And because divider resistors, if they are there all the time, it increases the consumption current a lot. They also put a switch so that they sample the battery voltage only when they want to and kind of sync in with the sampling of the ADC. So you have to add 2 resistors plus a switch. And as opposed to that, RICOH's solution with the integrated battery monitor is that we have integrated all these components, so you reduce components, plus you are able to match the input impedance of the ADC. All you need is an external capacitor at the output of the battery monitor. And the additional IQ, as opposed to just a plain LDO, is only 100 nanoamperes. So this integrated solution brings a lot of value. It reduces the mounting area with a compact package and fewer external components.
Is there anything else that we should add to this discussion?
The value that RICOH brings to IoT applications. First, we have energy harvesting solution with the R1800. It has ultra-low startup power, ultra-low IQ, and it works with that maximum power point control operation. What we have with the RP604 is the ultra-low IQ buck boost DC-DC, which extends the battery life, and it also accommodates a variety of battery types. Also, the RP124 is an LDO with a built-in battery monitor. This is a unique offering from RICOH, and it simplifies the design. It reduces the external components. You get ultra-low IQ, so you can continue to reduce the drain on the battery, and you also benefit from the fast transient response.
Thank you, Sanjeev, for joining me today to talk about power management in IoT, which is going to be more and more critical as designers look to extend battery life. If you'd like to learn more about RICOH electronic devices, power management ICs, or the RIoT board, click the links in the description or visit Mouser.com. And be sure to check back soon for the next episode of Tech Chats.